The Data Import Wizard is very important because it enables us to import and manage our external objects into the treatment plan. In this example, you can see that we have an anatomy STL file, as well as a wax-up STL file. If we click on the I button, we are able to turn on our 3D objects. "3D objects can also be managed by the Objects menu located on the top right-hand portion of the screen. This menu can be dragged around, and we can use it to toggle the visualizations of our objects here as well. All objects can be edited, superimposed, and visualized. We can also access the menu to manage these objects by right-clicking on the object itself. Here, for example, we can access the transparency tool. We can also alter the object type. Every object that we import, either from the patient list or directly from the import button, is assigned to a specific object type. For example, this object is the anatomy object, which is related to the arch where we are going to be placing our implants. This is automatically assigned to the Quick Visualization button located in the small 3D toolbar. The object color can also be adjusted, and you can see that the menu for that is accessible through the tools we discussed before. However, the most important variable that we're manipulating in this step is superimposing the STL file to the DICOM data. To do that, we will highlight the STL file and click Matching. We will confirm that we are matching the anatomy file and click OK. Now we will see that the STL file we are trying to superimpose is on the right-hand side of the screen and the DICOM data is on the left-hand side. There are a couple of different ways to superimpose the images. The first is by specifying points. Select at least 3 corresponding points in both data sets and click Fit Points. The software will create a rough superimposition, but this is usually not sufficient. We will now need to select the Best Fit tool, in which the algorithm will auto-detect the surfaces on both objects and fine-tune and optimize the positions. Another way to conduct the superimposition is to let the software help you without placing any points at all. To do that, we will click on Assisted, and the software will try to detect the surfaces between the DICOM data and the STL file and propose the optimal match. In all scenarios, the match should always be verified by scrolling through the different views and confirming that the STL is correctly aligned with the anatomy in the DICOM data. We're able to verify the match in each view by utilizing the different bars and sliders to scroll through the image slices. As always, we can use our right mouse button to zoom in and out of the image. If the match needs to be fine-tuned, we can edit the rotation or the positions. We can also use the small arrows for more precise adjustments. Clicking on Undo will bring back any changes that were made. Once satisfied with the superimposition, we will go ahead and click Apply. Now the anatomy STL is correctly aligned with the DICOM data, but as you can see, the wax up is still in the original coordinate system. We will select the wax up and click Matching, but this time we will choose Same as Anatomy. This will perform a mathematical transformation to align the wax up STL with the new coordinate system of the anatomy file. Click OK, and the software will automatically reposition the wax up. The same could be done for any additional objects that are present, or we can import new objects, specify their object type, and proceed with the matching steps accordingly.